Well, welcome to the second part of our unit on atomic structure. So I'm going to do a quick recap of what we saw in part one, kind of a little history lesson on how we understand what these tiny little things called atoms really are. So I found some nice diagrams in the textbook, which you don't have right now necessarily, so I'll just kind of run through it with you. We started out, once we started understanding that there are things called atoms, and we got the technology to study some of the effects of these atoms. So around 1800 or so, John Dalton proposed that there's just this solid, uniform little sphere, and there was no like internal structure or anything like that. You can almost picture like a billiard ball or a bowling ball or something like that. Nothing too interesting about it. But then about 100 years later, J.J. Thomson said, no, I think there's some parts to it. There's evidence that there's some positive part and some negative part. So they had studied a little bit of electricity at the time and realized that there were these things that we now call positive and negative charge. But he had them kind of all mixed together like a hodgepodge. It's often called the plum pudding model, or I like the example better, a little more modern, because we don't eat plum pudding much here in the States, of like a chip ice cream. So you got the ice cream, but you got the chips all mixed in. So that would be like the negative charges mixed in, little dots of negative charge all around the positive charge. And then not long after that, Ernest Rutherford said, you know, I did this experiment called the gold foil experiment, and I found that these alpha particles will bounce off of something in the atom. Well, in the plum pudding model, there's really not much to bounce off of. So in the Rutherford model, he proposed that there is a positive center to the atom. And it's a tiny, tiny little thing. Call it the nucleus, and we could never ever draw it close to even to scale because it would be too small to even see. So we show a greatly magnified version of the nucleus here. And then all the other stuff, the negative charges, are moving around all sorts of haphazard ways. Okay, so those were getting closer and closer to a pretty good model. But what I'm going to describe to you today is what we actually use here in our study of chemistry. And it's not actually the best model of the atom, but it is the one that's probably the easiest for us to use and to describe different behaviors that we see, and it is known as the Bohr model. So let me show you a little bit about the Bohr model, because that's the one that I'm going to want you to be able to represent like on a piece of paper. So remember, I want you to be able to have some notes down that you can refer to as you do your work, because I don't expect you to have a super memory and just retain all of this stuff in your brain. So this could be like on a second page after you did your first one. Hopefully things are organized nicely in a little spiral notebook or a binder or something where you can keep things in order. Okay. So we'll call this Atomic Structure Part 2, which is the Bohr model. So this is named after a scientist, a Danish scientist named Niels Bohr. So we use B-O-H-R as the spelling for that. Okay. So I want to describe, before I draw, I want to describe some of the features of the Bohr model. So he definitely knew from Rutherford's experiment that there was this small little nucleus. So a tiny center, okay, it contains positive, and at the time he didn't necessarily know what the names for these things are, but we have come to call these positive little particles protons. Okay, they are what give the nucleus its positive charge characteristics. That's one of the things that Rutherford had discovered. He knew that it was positively charged. The way it, you know how like sometimes you get laundry out of the dryer that will kind of have static electricity. It was a similar effect, the way these alpha particles bent around away from the nucleus. So he knew that they were positively charged. We have come to learn, it wasn't long after Bohr started his work, that another guy discovered there's something else inside the nucleus, but it doesn't affect the charge at all. And they are, so we call them neutral instead of positive or negative, and they're named neutrons. So even though it's the tiniest little part of an atom, it actually contains two of the three really important particles in the atom, and that is the protons with the positive charge and the neutrons with no charge at all. Okay? And then the electrons are also the important part. So again, Rutherford knew there were electrons. He just kind of had them going haphazardly around. But these are seen in the Bohr model as orbiting at fixed locations that we call energy levels. Remember, as I start to talk again, if you're still writing, you can always pause the video, okay? So instead of, again, kind of all over the place, they're in certain locations, much like planets around the sun. Okay? So in our solar system, the sun is the very dense center, and all of the planets, there are 8 of them, orbit in these fixed locations at certain speeds, all kind of different orbits from one another. And remember, those orbits are super, super far away, okay? No way to really accurately represent, for the picture of an atom, just like there's no accurate way to represent how big the sun is compared to the size of the orbits of the planets. It's just too difficult to scale, okay? So that describes where they are. They also have a characteristic we call negative charge. It's hard to describe what charge really means. It's just a description of something, and it's probably the most important characteristic of protons and electrons is the fact that one of them's positive and one of them's negative. Okay, you may have heard the phrase opposites attract. Well, the thing that keeps the electrons around the nucleus and orbiting is the attraction of the nucleus for that electron. It wants to kind of hold it in tight, much like the sun's gravity wants to hang on to all the orbits of the planets around it. That's what keeps us in our orbit. So one of the things I'm going to want you to be able to do is to draw and label a little diagram. So I'm going to draw a diagram, and I want you to draw right along with me. Even though you're not necessarily an artist or anything, I still think we can represent this pretty well. And you'll see a lot of times diagrams drawn for you already, in which case you would just have to label what the different parts are, maybe the nucleus or the protons, neutrons, or electrons. So let's kind of do it this way. First, let's make a little key. So we'll have a little plus sign represent our positive protons, and a little minus sign can represent the electrons. And again, that's a great way to do it because it identifies the most important feature of those, and that is what their charge is. And because the neutrons don't have any charge, let's color those in like this. We don't need to put anything inside of them. So those 3 kinds of dots, let me zoom in here a little bit, can represent the different kinds of particles. We call these subatomic particles. Sub meaning under or below. In this case, it means it's the stuff that makes up the atom. And so first let's draw the nucleus, and then we'll draw the electrons around it. Now the nucleus, remember, contains these positive protons and the neutral neutrons. Now it's supposed to be a super, super tiny thing, but obviously with my pen I can't really draw it that small. So let's just draw a handful. Now I need to have a little space around me, so that's why I'm using kind of the center of some space here. And how many you draw kind of depends on the atom. So let's just draw 7. How's that? Okay, so there's 6. We'll draw a 7th one here. That's going to be our nucleus. It's supposed to be drawn kind of a little ball, but it's hard to make a perfectly round shape from 7 different little round shapes. And we'll have 3 of them be plus protons. So we're just going to maybe spread these out a little bit like this. Doesn't matter which ones are the protons. So those 3 can be protons. And then our neutrons, those other 4 we'll color in. Okay, so remember what our key looks like. Those shaded ones are neutrons, and the ones with plus in it are the protons. And then the electrons, we have to draw them in orbits. Okay, now there's a little more detail than what I'm going to put here, but for now, we can't scale it. Remember, if I was going to scale it this big, remember, if I make my nucleus the size of a penny, I need to put my electrons like a mile away or a half a mile away. That's not going to work. So we just kind of scale it down a little bit. Very lightly, we'll draw a little circle. And that'll represent our first energy level. And no, your circle doesn't have to be perfect, kind of like mine isn't perfect. And let's put a couple of electrons there. So here's one. There is a reason I'm only putting 2. Turns out that the energy level that's closest to the nucleus can't have any more than 2. So it either has 1 or 2 in it. And then we'll put another energy level out here. Again, trying to draw roughly circular shapes, but I'm not going to grade you on how good your circles are. And we'll put another electron out here. Now on the atoms that I'm drawing, I'm going to try to keep the number of protons and the number of electrons identical. So I had 3 pluses in the nucleus, and I'm going to put 3 minuses out here. Okay, again, there's more that we're going to learn about that. Right? So that's what a simple atom would look like. Right? So if you can draw that, that's great. Let me show you what our textbook has for a model. Zoom in here a little bit. They do not have on their diagram the protons and the neutrons separated, okay? But this positive charge is the nucleus, and it does contain both of those. And then here they've got a total of 8 electrons shown on this one. 2 on the first energy level and 6 on the other. Again, all I want you to be able to do is to represent these orbits and to put some electrons in there, and later on I'll describe how you figure out how many of each goes on the different energy levels. Okay, so there, and you can see the year here. Again, we're all kind of early in the 1900s when most of this stuff was discovered for what the Bohr model looks like. All right, this last little bit for today, I want to just make a little table of the different properties of the protons, electrons, and neutrons. So those 3 particles are known as subatomic particles because they are the particles that make up an atom. So sub means like below or within something. Okay, it kind of makes sense. So I'm going to know that phrase, subatomic particles. So our table will look like this. We'll have a line for each of the particles. So it'll be like one for proton, one for neutron, and one for electron. And what we're going to write about it is the location of each one, the charge of each one, and the mass of each. Now, this is just a summary of what we described on the previous page. So the location of the protons and the neutrons are in the nucleus. And if you need time to make that table, you should be pausing here so I don't get too far ahead of you. And where are the electrons located? Those are those orbits known as energy levels. In the Bohr model, that is. Okay. Again, a more modern, accurate view of the atom doesn't quite describe it that way, but this is going to work well for us in this class. And then each of these particles can have a charge, the protons being a +1 charge, electrons being a -1 charge, and the neutrons have no charge at all. They are called neutral. And the mass, again, this is such a tiny little thing. The mass is like how heavy something is, if you want to describe it that way. It's not like you can throw this on a scale and measure it. So I'm going to give you what we call relative masses, like just how much mass something has compared to the others. So it turns out that the protons and the neutrons have almost identical mass. So we're going to call those each 1. Okay, if they each have a mass of 1, the electron is so tiny, it is less than, or just about 1/2000th of the mass of a proton or a neutron. Technically, it's about 1/1836th of a proton. Okay. Now that's so small that we usually say that electrons have no mass at all. Okay. Now something to remember is those things are moving in the Bohr model. They're orbiting around in these energy levels, whereas the protons and neutrons are kind of stuck in place there inside the nucleus. And it kind of makes sense because these are very massive compared to something that's 2,000 times lighter. So if something's going to move in the atom, sort of makes sense that would be the light thing in there, right? Okay, so I think this is plenty for now. We're over 15 minutes. So we'll stop here, and then we'll continue on, and I'll give you a little bit more detail on some of those things I was talking about before with how many electrons are in each energy level. But we got enough to start with here. So thanks for watching.